Hey guys, Bing here. Today I'm going to talk about some simple trigonometries, which is very useful for Revit family. So this is the Wikipedia page of the trigonometries, so you can have a look. So basically, the most useful, most common one we're going to talk about is these. So sine A, cosine A, tangent A. So I'll quickly do a screenshot of this. So see this one. So this is the triangular shape with a right angle here. So if we know any two of these, so A, B, C, the length of A, B, C, or the angle A and B. So if we know any two of them, so we can get the rest of the rest three. Okay, so for example, if we know A, H, the length of A and angle of A, so if you can go here, and we can get the B. So from this, hang on, let me check which one. So it's A and B, so which is tangent A. So you can use this formula, tangent A equals, see this one, A divided by B. So A divided by B. So if we know A, and then we can get that the B. So B equals A divided by tangent A. Okay, so and you can also, so if we know A, and if we need to calculate the C, so the same, so we can use this. So sine A, so sine A equals A divided by C, and then we can get C equals A divided by sine A. Okay, so yeah, and also because it's a right angle, so we all know that A squared plus B squared equals C. So you know any of two of the three length, you can get the other one. So for example, if you know A and B, you can get C squared. So you know C, so C equals square root of A squared plus B squared. Okay, so if you know A and C, so B equals square root of A squared, C squared minus A squared. Okay. And also angle, for the angle, if you know, because this is 90 degrees and the three angle, the sum of these three angle equals 180 degrees. So which means if you know A and then B equals 90 minus A. Okay, so these are most of the very simple, very basic ones. So sine A, cosine A, tangent A, and also let me check. So these ones, inverse trigonometry, so which is arcsine, arccosine, arctangent. So these are used to calculate the. Oh, sorry. I'll just draw it here. So still the same. This is so A, B, C. This is B, and this is A. So these are used to calculate the angle. So still, so for example, if I know A and B, so we can use this arctangent. So hang on, let me go back to the tangent. So tangent equals, so see this one, tangent A equals A divided by B. So because tangent A equals A divided by B, right? So A equals arctangent A divided by B. Okay, so in Revit you can just type in ATAN. That is arctangent. Okay, and arccosine is ACOS. and arc sine is ASIN. Okay, so let me just do another one. So if I know arc, let's use arc sine. Okay, so because sine A equals, so if you go to the sine A, here sine A equals A divided by C equals A divided by C. So angle A equals arc sine A divided by C. Okay, so yeah, that's it. So now let me just do a very quick example. So show you, I'm going to create a truss family. Okay, so in this truss family, so I'm going to, so I'll just do a screenshot of this. So I'm going to draw a truss, something like this. So for a scalene roof. Okay, so and because this is 90 degrees, so see this one, this is H, and this is length, L length. So in so if we use this oh sorry, this will be, let's say this is A. Okay, so this is B, this is C, this is A, capital A angle, this is B, of course. And now okay, I'll create this truss first and then explain to you. So first, truss top core, so from this to here, and then bottom core here to here. And then I'm going to create some web, and also I'll just do some reference plan and equal them. Okay, so I'll equal this one and also another one here. And then I'll do some web, maybe from here to here, and then here to here, and here to here. So that's it. So this is a truss, and if I create a new project and load, hang on, let me just model a house. Okay, so this is some wall, and I'll create a roof, and select all, maybe. And also uncheck the define slope, and also define slope one of the side, and then create this attach. So now this is a house with a scalene roof, and also I'll maybe change the pitch to 15 degrees. Okay, so this is my house. Go to ground floor, then load this truss into this project. I'll draw it from here to here. Let's have a look in 3D view. I'll temporarily hide this roof, and also I'll change the height of this truss so it goes up to the top of the wall. Okay, about right. And then okay, so let me show the roof now. So as you can see, the pitch of the truss is not matching the roof. Okay, so the roof currently is 15 degrees, but the truss, I don't know what the pitch is. So see, there's nothing at all. Nothing here, nothing here, nothing. So to adjust the truss, we need to type in a number, a height, so to make it to match the roof, but I don't know what this height need to be. So we can probably we need to go to elevation and do a dimension, and then just type in that number. But it's very quite annoying. So even if you adjust so I'll show you, if you just change the width of the wall, and if you adjust the length of this truss, you will see that we need to adjust this truss again. So the roof is still 15 degrees, but because the height stays the same, and then the pitch of this truss change. So, and then sometimes it's very yeah. So even if you have different roof pitch, so yeah, it's very hard to match the roof. So what we can do is, so if I go edit this roof, so what we can, because we know that this is the length, this is the height, and if I go to this, we know this B, we know this A, and can we use the formula to calculate the A? Yes, of course we can. So if I go there, so this A, B, so we know A and B. So from here we know A and B. So we know that tangent A equals A divided by B. So if I write this tangent A equals A divided by B, so the angle A equals arc tangent A divided by B. Okay, so let's go to Revit, and here we just need to create. We don't need to add a dimension. Don't add a dimension. Okay, so you will over constrain it. So I'll just create a angular. So make sure you change this to angular, otherwise it won't work. And instance and OK and OK. So now if I go to family types, and here I'll type in that formula, arc tangent ATAN bracket, so A divided by B, which is A is here is the height, so is truss height divided by truss length. Okay, so apply. So see, that's 6.84 degrees. Okay, once again, don't add a angular dimension here. Do not. Okay, so now if I load this to the project and select this truss, it tells me the angle is. So it tells me what this angle is, but it's gray out. You won't be able to change the angle by just typing the angle. No, you can't. So you can still change the height, but it tells you what the angle is. It's still not very good. It's better, but still not good enough, because we want to use the typing the angle, and then then the truss change the truss height. So what we need to do is go back to this family and go to family types. So instead of have this formula here in this angle, just let's delete it. Okay, so we know this angle because we need to type in. So once we type in, we know this angle, and also we know the length because we place this truss across this building, so we know this length. So we just need Revit to calculate the height for us. So let's go back to here. So now this time we know B and A. Okay, and it's still same formula. So we know we know B and A, angle A. Yeah. So we need to know what the A is. So from this formula, we can get A equals tangent A times B. So this is the formula for the height. So go back here. Oops. Sorry, where is it? Here. Height equals tangent A times length. So truss length. Apply and OK. So now if this time if we load this right, and then let's try this again. So now we have we still have this truss height, just don't touch it. So this time we'll only change the angle. So for example, if I change this to 10 degrees, see, this now this truss will be 10 degree, and if I type in 15 degree, so now this truss will match the roof pitch. Okay, so and also if you adjust the length of this truss, you will see the pitch of this truss stay the same. Okay, so this is a very simple example of how we use some trigonometry to control the formula or control the parameter. Okay, so now let's go back to, I'll just close this one and close this one. Let's have a look at this page, so and see if there's anything else we can talk about. Not quite sure about this. And so this pattern might be useful when you use Dynamo, I think, but I'm not very good at Dynamo, so I'll just leave it to you. So arc sine, arc cosine, arc tangent, we've already talked about this, so that's okay. And these are not too complicated, so I'll just pass. Not these, not these, not these. This might be useful to get a radius of a circle part, which pass all the points. I think. Yeah, I'll leave it to you. So, and also this is just any triangle shape. It's not just right angle triangle. So I think this is very useful. So, of course this one. So A1 to ABC, ABC, and you can get the angle C. So it might be useful, but I can't think of anything we can use this for. So I'll leave it. So this is quite useful. So do the area. So this is area. So previously I did one when I for one of the shade families to calculate the area. So I'll quickly do a family, adaptive family, to calculate the area of that family. Okay, so it will be I'll show you. It will be a adaptive family. So for example, we're going to model something like this. So I'll just quickly do another one, but this time will be a triangle. So 3-point adaptive point. So what I'm going to do is adaptive family. So where is 1, 2, 3, 3 points adaptive, and then I'll link this. So spline reference line, and spline reference line, and spline reference line. So what I'm going to do is I'll just create a shape. So this is the shape, and then I'll calculate the area of this shape. So what I'm going to do is hang on, let me just create a project and see if, because sometimes when we create a family, it will calculate the the area and the what's that called, sorry, I can't remember that one. So it's just the area. So there's nothing tell me what the area is. Yeah. And yeah, sometimes when we do some generic model with some extrusion, it will tell me what the cubic meter of that family is, but in this one, nothing. So okay, let's come back to this family. So what I'm going to do is, so because this is the adaptive family, we can get dimension. So I'm going to use, first let me make sure they are all reference line. Yep, all good. So DI, just set work plan. I'll pick the work plan of this reference line and to a dimension. So from point 1 and 2. So I'll create a parameter, reporting parameter. So let's call it A. Okay. So I'll create a second one, same, set work plan first. Okay, and then do a dimension from point to point. So this will be the reporting parameter B. And another one, set work plan, pick a plan, this one, and do the point to point. So this will be reporting parameter C. So okay, so now we know A, B, and C. So if I go to this page, so see this one, so A, B, C, we know A, B, and C. What we need to know is the area, so which is here. So area, so if you look at here, so here is the formula. Area equals square root of S times S minus A times S minus B times S minus C, and this S equals half of the perimeter. Okay, so let's do it. So first I'm going to create a parameter. Let's call it S. Is that capital S or lowercase s? Let's call it S. Okay, so S is length. Yes, length. So instance, and okay, so the formula will be half of A plus B plus C bracket divided by 2. So the reporting, something's not right. Yeah. Okay. So which means, let's go back. Something's not right because when we create, this happens a lot to me. So when we create the dimension, it's very important to make sure you place on the correct the point. So what I'm going to do is just delete everything. Let's do it again. So select, this time I'm going to isolate the points. So 1, 2, and 3 adaptive points. Okay, and HI, isolate. Oh, hang on, I still need the reference of the work plan of the reference line. So HR, let me just select 1, 2, 3 as well as the reference line. Okay, so if you click on filter, you will see there are 3 reference line, 3 adaptive points selected. Click OK, HI. Okay, so now let's do it. So set work plan, pick a plan, pick this DI, and make sure you pick this point and this point. So this will be A. I'll just associate with A. Okay. Once again, set work plan, pick a plan. Okay, pick this work plan, DI, dimension point to point. So this will be B. Again, set work plan, pick a plan. Okay, pick this one, DI, point to point. So C. And let's try it again. So I think the reason why it didn't work is because we have this face surface, or what's this called, the form of face. So that's something like maybe when we place the dimension, we place on this face instead of on this point. So let's try the S again. So create S parameter, length, instance, okay, and then bracket A plus B plus C bracket divided by 2. Yes, so now this time it works. S, apply, okay. Let's have a look again. So not this one, this page. So this time we're going to type in this formula. Okay, this one. So the area, so same. Let's go back to family types. So this time create a area parameter and make sure make sure change this type of parameter to area. Okay, and then instance and OK. So now we can use that formula, so which is sqrt square root of bracket s times s minus a bracket, oh hang on, times s minus a times, hang on, is that times? Yes, s minus a times s minus b times bracket s minus b bracket times bracket s minus c bracket. Okay, so now 135 square meter. And okay, so yeah, I think that's it. So now let's load this into the project. Override, and then click on this family. So now it tells me where's area here. So this is 44 square meter. So this shape. So let me have a test. So if I draw some, so maybe I'll make this 1 meter and this is 1 meter. So we know that this, if we create a triangular shape from 1, 2, 3, it will be half square meter. Okay, so because this is 1 meter, this is 1 meter. Okay, so let's try this. So CS, so 1, 2, and 3. Let's have a look. Yes. Okay, so this is another very simple example of trigonometry, and I think that's it. These are too hard. So yeah, have a look of this page if you're interested, and yeah, if you have any question, please let me know. If you have some good ideas, recommendation, please let me know as well. Okay, thank you. I'll see you next time. Bye.